Hey everyone, welcome back. So in the last video, we covered the fundamentals of JWT, what JWT is, what is the general authentication flow with JWT. Now in this video, we will do the hands-on, we will develop a backend service which will expose a protected endpoint. And then using Postman as a client, we will access that endpoint using JWT token. So let's get started. So as we discussed the authentication flow in the last video on JWT fundamentals, we remember that we need a user store. Why we need a user store? Because we haven't covered anything about OAuth, which is generally used with JWT. So we need a user store to store the user so that we can implement the authentication flow. We can later compare the username and password. Now this authentication is required because after this authentication only the server will generate a JWT token that the client can send in subsequent requests. So in this case, in this hands-on session, what we will do, we will have a user store. We will use Postgres as the database, and we will also implement a user registration flow. In this user registration flow, the user would register itself and the details will be stored in the database. And then we will develop the authentication flow in which the user will provide the username and password, and we will write the logic to authenticate the user based on the username and password. And we will be able to do so because we will have the data in the user store, which is the Postgres database. So after this authentication, the server will generate a JWT token that will be sent back to the client. And then we will implement the protected endpoint flow where we will implement the validation of JWT. How can we validate the JWT token provided by the client? And if the JWT token is valid, then we will let the user access the protected endpoint. So let's start with the user store implementation, which is the user registration flow. So this part we have done multiple times in this playlist, the user registration part. So I'm not going to cover this part from scratch to save some time. So to save some time, I have already implemented the user registration flow, and I will give you a complete walkthrough so that you can do on your own. And then we will start implementing the authentication flow and JWT part together. So let's start from the pom.xml. Let's understand the dependencies that we have at this moment. Now we need starter data JPA because we need to store the user data in the Postgres database. We need starter security. We need starter web because this is going to be a web application. Then we need the Postgres database driver. In case you choose another database, you need to update the driver. Then we have Lombok to generate getters and setters, and then the test dependencies. As you can see, we do not have any dependency related to JWT yet. We will add them as we go. Alright, so you can create this simple project by going to the Spring Initializer, just add the required dependencies that I have highlighted, download the project and start implementing the user registration part. The second important thing is application.yaml file. You can ignore the secret key for now. This is going to be used in the JWT flow and I will cover it later. But if you just focus on other properties, this is the name of the application, this is the database details. So that is the database that we are going to use. And if I go to Postgres, you can see this is the database that I have created. Now this database does not have any tables as of now. This is empty. This application will create the missing tables on server startup because we have provided this property hibernate DDL auto to update. And then we have the database dialect for Postgres. So that is the minimal configuration that we need in this Spring Boot application. So let's now go to the registration part. So here we have the registration controller, which is exposing an endpoint API auth register. So the client would hit this endpoint to register itself into the system. And this endpoint is accepting a user DTO. And if we check the user DTO, it has three details: username, email, password, and role. Now in this demo, we will also implement the RBAC, which is the role-based access control. So in this case, the user would have a role field as well. All right. Now this data will be stored in the database. So let's go back to the controller. Once we have the data from the request, we are calling the user service to register the user. And if the service returns true, then that means the user has been created successfully. If not, we will return a response, which is the error response. Let's now go to the user service. So in this user service, we have the register user method, and here we are creating a new user. Now this user is the JPA entity. So let me open this up. And you can see this is the user entity, which is mapped to users table. And it has several fields like ID, which is the primary key, username, email, password, and the role. And you can see we are storing the string values of the role because role here is an enum. So let's check this out. And you can see we have only three roles: admin, user, and guest. So when we store the user via user JPA entity, we will also store the role of the user, which could be admin, user, or guest. Alright, going back to the user service. So here we are creating the user basically using the JPA entity. So we are setting the username, which is coming from the incoming request. Then we are setting the password, email, and role. For the password, you can see we are using password encoder to hash the password. This part we have already covered in this playlist. And once we have the user JPA entity enriched, we are using the user repository to save the user. Now, if I check out the user repository, you can see this is simple Spring Data JPA repository extending the JPA repository, and it has a method find by username, which is a custom method. I will cover this as we go. So this will save the user data in the database, and that is going to be the users table, which is mapped to this JPA entity. So as you can see, this service is also implementing the user detail service, and we have covered this interface already in this playlist in the HTTP basic demo. So this interface is a way for Spring Security to know how to load the user. Spring needs to know how to load the user. And by using this interface, we provide the implementation of load user by username. So what Spring Security does, it simply calls this method, and how we implement this method is up to us. In the end, it returns a user details, which is the loaded user itself, and that's how Spring Security loads the user in abstraction. All right. So that is why we are implementing this interface, because we need to authenticate the user, and to authenticate the user, we need to compare the username and password. To match the username and password, we need the user data. That is why we are using user detail service. So in the authentication flow, what will happen? The framework will use this method to load the user, and then we will write the username and password matching part before generating the JWT token. So that is why this implementation is required. So because we are implementing this interface, we need to provide the implementation of load user by username, which is accepting the username coming from the incoming request. Then to find the username from the database, because in this case the user store is Postgres database. So that is why we are fetching the data from the database. Suppose in other scenario, we could have an external API that will return the user. So instead of fetching the data from the database, here we will write the logic to fetch the user details from the external API. All right. So here, because we have the data in the Postgres, so we need to access the user repository, and we need to find the user by name, not by ID. That is why we have added this custom method find by username. Then once we have the user data back from the database, we are creating something called authenticated user, and this authenticated user is nothing but the implementation of user details. All right. Now user details has several methods like get authorities, get password, get username, and this is the username and password detail coming from the entity that we have just loaded from the database. Then the next important thing in this entity is the authorities section, because we are also using roles in this scenario. The next important thing to understand here is the authorities. Now in this case, because the user can have the role, so we need to return the correct authority so that the role can be compared. Now this part we have already covered in the roles and permissions video, so please check out that video to understand the core principles of roles and permissions in Spring Security. Alright, in a nutshell, the authorities or the roles and permissions are called authorities in Spring Security language, and these are represented by granted authority. Then we have the implementation of granted authority as simple granted authority. So from this method, we will return the list of all the simple granted authorities, basically all the roles or permissions this user would have. Now in this demo, because each user would have a single role, that is why we are returning a single simple granted authority object. Now the value of this object will be the role of the user with a prefix role underscore. Now in that video that I'm referring, you will find that any string can be used as a role as well as a permission. So how do you distinguish between the role and the permission? So if you prefix role underscore with any string value, that particular string value will be treated as a role, not as a permission. So because we are going to implement the role part, that is why we are prefixing role underscore. All right. So from this user, what we are returning is the username, the password, and the role of the user as simple granted authority. Then we'll go back to the last part, which is the security config. And here you can see we are creating the bean of password encoder that we are using in the user service to hash the password. All right, and then we are configuring the filter chain. This is not complete yet, but we will complete this as we go with the remaining bits. For now, you can see that we have disabled the CSRF as always, because this is going to be a purely backend application. Then in this section, we are matching the endpoints and we are permitting API auth register endpoint. So you can see if the request matches this particular pattern, then we need to permit all. Otherwise, any other request will be authenticated. Now, one thing you should notice here is that this does not have any information related to HTTP basic as we have been doing in the previous videos. Although we are implementing user detail service and storing the data in the Postgres, but we are not going to use HTTP basic authentication mechanism in this case. We will use JWT and we will cover the details. How do we match the username and password? How do we authenticate the user without using HTTP basic? All right. So now that we have covered the basic project setup, the user registration part, we will now move on to the authentication part, where we will authenticate the user and we will also generate a JWT token. So before we start the implementation, we need to understand some key things about the implementation. This is the GitHub page of JWT for Java, and you can find almost all things related to implementation on this README page. So I suggest you go through this README page and check out the details how to implement JWT. Let's go through this together. So here you can see many sections like installation, where we will find the required dependencies. Then we see section creating a JWT that will tell you how to create a JWT token. Similarly, we have section for reading a JWT. So once you have the JWT token, how do you parse the JWT token? Then there are details how to sign the JWT, how to encrypt the JWT token, and all these things. So we can start with installation. And here we can see the required dependencies that we need in order to implement the JWT. So we'll have to add these dependencies to our pom.xml. Then in the quick start section, here we can see a simple flow of how to create a JWT token. So we need to first use the builder, and then we can add the claims. Like in this case, we are adding the subject, then you sign the token, and then you create the token. And you can see to sign the token, we need a key, and that is where we are creating the secret key. And this is the same reason why we added a secret key in the application.properties file. And you can use the same example, this line of code, to generate a secret key. You can pre-generate the key by calling this code, and you can just copy the secret key and add it to somewhere, let's say application.properties or a vault. All right. So once you have the secret key, you can use the key to sign the token. And in this example, this represents your JWT token, which is signed JWT token. And in the same way, we will create the JWT token from the service when we return a token back to the client. Now, in the subsequent requests, when the client sends the token, how do we parse the token? And we can see the example over here that we use the parser, then we verify the token with the same key. That is why we need to store the key to a common place that can be used while generating as well as parsing the token. So once we verify the token, we get something called signed claims because the token was signed. And from the signed claims, we get the payload, and from the payload, we can get all the claims which were added to the token, like subject in this case. Or if you added some custom claims, we can extract that information as well from the payload. And we can see more details under respective sections like creating a JWT. So things that we have covered, we need to use the builder. Then we can add headers if we want to. Then additionally, we can add other things by using the builder methods. Then we can either sign the token or encrypt the token. So there are two methods to sign the token with a key. We use the method sign with. To encrypt the token with an encryption key, we use the method encrypt with. And then we call the compact method that produces the result as a compact JWT string. And here we can see the sample that we are using a builder. Then this is adding some optional headers. Then this is the subject. And then you can also add custom content to the payload. Here is an example. Then you can sign the token with a signing key. And if you want to encrypt it, then you can call encrypt with method with a encryption key. In this case, you also need to provide the encryption algorithm. So that is how we generate the JWT token. And similarly, you can find other details like how to add custom headers to JWT. This is all here in the documentation. Let's move on to understand how do we parse the JWT token. All right. So this is the section where it tells you how to read the JWT token. So to read a JWT token, we need a parser, which is a builder method. Once you get the parser, we need to verify the token. So if the token was signed, then we verify the token with the key. If the token was encrypted, then we need to decrypt the token with the key. Then we call the build method that will generate a JWT parser. Here you can see. And then we need to call the parse methods to parse the token. And here we can see the example. We can simply call the parse method, or we can call parse signed claims. Let's say if the token is signed, if the token is encrypted, then we will call parse encrypted claims. So you can find the example here, and we will also see the example in the project as well. So you can go through all these details related to keys. So you can find more information here, like how to verify the token, how do you encrypt the token. All these things are given over here. And similarly, you can find the details related to the signed token and encrypted token. So here you can see signed JWTs, and these are the algorithms which can be used to sign a token. All right. And similarly, you will find the information related to encryption as well. So this is telling you how to create a JWS. JWS is nothing but a signed JWT token. A signed JWT token is called JWS. And similarly, encrypted JWT token is called JWE, which is encrypted JWT token. And we can find the same on the documentation somewhere over here, encrypted JWTs. Okay, this is JWE encryption algorithms. So there is a lot of info on this README page, and you can go through this in your own time. But we got the gist how to create the token, how to parse the token, and we will use this information in the project. So let's move on with the hands-on. Okay, so the first thing that we need to do is we need to add these dependencies to the project. So let's do that. We'll go to the pom.xml and we'll add the required dependencies. We can add anywhere in the project, and then we need to reload the dependencies. So once we add the dependencies, the next step is to implement the authentication flow. So if you go back to the diagram, we know in the authentication flow, the client would register itself. All right. So the first thing is to register the user that we have already done. So the user is already in the database. Although we haven't run the program yet, but we already covered the implementation. That part is already implemented. So in the authentication phase, the client would enter the username and password. Then the backend service would authenticate the user. And if the user is present in the system, if the username and password is matching, then the server would generate a JWT token and it will return the JWT token. So we need to implement this authentication flow. So let's do that. To intercept the authentication request, we will add a new controller, and that will be the authentication controller. And this authentication controller would be a REST controller. And in this REST controller, we will add a new method, login, which will be a post mapping. It will be a post call, and let's give it an endpoint, API auth login. All right. Now in the request, we will get the data from the request using request body annotation, and we will also create a record in this case to capture the information. So that will be the login request, like this. And in the same way, we can generate the response, because in the response, we need to return the token. So we will also create a response DTO in this case, which will be login response. Okay, so let's create the missing DTOs. This will be a record, login request. And this record would have two fields, username and password. Like this. And similarly, we need to add the other DTO, which is login response. And in the login response, we would have a single field, which is the token. Like this. So in this login endpoint, first we need to authenticate the user. Then we need to generate the token. And then we need to return the token. All right. So how do we authenticate the user? So to authenticate the user, because we will not be using HTTP basic, so we need something called authentication manager. So for now, what we will do, we will simply auto-wire the authentication manager, and later we will also configure the authentication manager. So suppose we already have the authentication manager, then auto-wiring the authentication manager is as simple as just using the auto-wire annotation. Like this. So once we have the authentication manager, how do we trigger the actual authentication? we use the object of this authentication manager and we call the method authenticate. So if we check out the authenticate method, we can see that this is an interface. That is why it has a single method, because this is a functional interface. And the authenticate method accepts an object, a type of authentication. So how do we pass the authentication object? Now in this demo, because we are going to use the username and password, but not the HTTP basic method, so we will pass an object of username password authentication token, this one. And it accepts two parameters and sometimes three depending on the constructor that we use. You can see the first one is principal, then the second one is credential. And for the second constructor, the third parameter is authorities. Now we are going to use the first one, which will take the principal and the credential. So what is going to be the principal in this case? Principal is nothing but the username, and we get the username from the incoming request using this DTO. And the credential would be the password. All right. Now the authenticate method would return an object of authentication, this one. All right. So how would this trigger the authentication? Since we are passing this authentication token, which is username and password authentication token, to the authentication manager, so authentication manager would check from the list of available authentication providers that which authentication provider can handle this type of authentication. Now we have already covered the concepts of authentication manager and authentication provider in the first video, where we covered the overall architecture of Spring Security framework. So if you don't understand the authentication manager and authentication provider, I suggest you check out that video first. So in this case, authentication manager would check the list of authentication providers to see if there is an authentication provider available that can authenticate the user depending on this authentication token by username and password. Now what happens, by default there is an authentication provider which is made available to us by the Spring Security framework, and that is DAO authentication provider. DAO authentication provider internally uses user detail service, and if you remember, we are already implementing user detail service. So when we pass this username and password authentication token, it will trigger the authentication provider, which is DAO authentication provider, and DAO authentication provider internally will call the user detail service, this method load user by username. That is how this will fetch the user by the username, and it will also match the password. All right. So as a result, we will have the object of authentication, which basically represents the authenticated entity in this case. All right. So once the authentication part is done, how do we generate the token? Because if we go back to the diagram, we see once the authentication is done, user authentication part, we need to create the JWT token. So how do we generate the JWT token? To generate the JWT token, we will write some code that can use this authenticated principal and can generate the JWT token. So to generate the token, we will add a JWT service. Let me add the placeholder. All right. And then we will use this JWT service, which will have a method generate token. And to this generate token, we will pass the principal in this case. How do we get the principal out of this authentication object? Well, there is a method get principal. And the principal, if you check the data type of this principal, this is an object. We need to convert it to a usable entity. And in this case, that entity is authenticated user. Why authenticated user? Because if you notice, this is the class that we created, which is implementing user details. What is this user details? If we go to the user service, user details is the object that will be returned by this load user by username. Okay. And which is a concrete type of authenticated user. That is why this is the principal that we will return. So generate token will create a JWT token, which will be a string. So we will save it to a string value token. And in the end, we will return the response. And in this case, this will be an object of login response. And this login response has a single field, which is token. So that completes the authentication controller, the auth controller. All right. And we need to add the service now. So let's add the service. We will add the service to the service package. We will also annotate it with the service annotation. And then in this service class, we will add the method generate token. All right. So once we pass the request to JWT service, we know we have to create a new JWT token. How do we do that? Well, we have already seen the example on the GitHub page of JWT Java, and we will use the same syntax. Basically, we will use the builder, then we will add the principal, some claims, and then we will generate the JWT token. So let's do that. So the class that we will use is jwts.builder.compact. But we need to add some details. So the first one is subject. Who is the subject for this token? The subject is the principal. All right. And this is the authenticated user. So what we will do, we will add the subject. Subject is the username who is trying to log in. What else can we add to this JWT? Well, we know we can also add some claims to the JWT, and we can also add custom claims as we covered in the last video. So there are two methods. The first one is claim, where we can add a single claim. This is the key, this is the value, and we can add multiple claims if we have a map using claims. So in this case, I will add a single custom claim. Let's do that. The key would be anything that I want. So I want to add the roles that this user have, because when we are creating the user, we are also storing the role of that user, whether it is admin, guest, or user. All right. So I can add the role of the user while generating the JWT token. How do I get the roles of the user? Well, if you go back to the user service, then here you can see I'm fetching the data from the database. All right. And this is the user JPA entity. And in the user JPA entity, we have the role property. So when we fetch the data from the database, from the users table, we will have the role in the JPA entity. Then when we are creating the authenticated user, you can see that it has a method getAuthorities in which we are using this role. So when we call this method, we will get the role string for that user. And that's what we will use here. So I would say principal.getAuthorities, and this is the method coming from authenticated user. Okay. So this is a single list, a list of single value. So getAuthorities dot stream dot map granted authority, get authority, and then we can collect the list like this. Okay. So what we are doing, because in this case, the user has a single role, but in general, a user can have multiple roles. So in that case, the user would have multiple authorities. So we are simply, because this is a list of simple granted authority. So we are getting the individual authority. Okay. We are mapping the individual authority to get the name, and then we are collecting them as a list. So that's how we can add custom claims. And here we are adding the roles as custom claims. All right. What else can we add? Well, we can add something like issued at, when the token is issued, which could be the current time, like this. We can also add the expiry time of the token. That we can do using expiration builder method. So in this method, we can pass an expiration time after which the token will be expired. So let's say that we want to have an expiration time of 15 minutes. So how do we do that? Well, we'll create a new date time. We actually have to provide the actual time, maybe in milliseconds or seconds, whatever you want. So I will do something like this: system dot current time millis. Okay, this is the current time. Then something like this. So that is going to be the expiration time for this JWT token. The last step is to sign the token, and we know we do this by using sign with. And you can see it has two methods: by passing it a key, or by passing it the key and the digest algorithm. So we will use this method, we will pass it a key. So how do we sign the token? Where do we get the key from? So if you remember, in the application.properties file, we had a property secret-key, and this is the key that I pre-generated. And we saw in the README section of GitHub page that there is a method that you can use to pre-generate the key. All right, so just pre-generate the key and store it somewhere and use it while signing the token. So I will use this particular key. So we need to read this property in the service class. So let's do that. We'll go back to the JWT service, and here in this class, I will read the property. Okay, so that property will be injected to this class and we will have the access to secret key. And then what we do, we parse this key. So we will say something like keys dot hmac char key for. Then there is some syntax that we need to use. I will show you the right place in the documentation on the GitHub page where you can find all these details. So decoders dot base64 dot decode and secret key. So that will generate a JWT token. What we are doing, let's recap. We are adding the subject, which is the username. Then we are adding a custom claim, which is the role of the user, issued at when the token is issued. Then we are setting the expiration time of 15 minutes. Then we are signing the token. Now this code is directly coming from the GitHub page. I will show you in a second. The only thing is you need to pre-generate the key. All right. So this will create the JWT token, which will be returned to the authentication controller, and the response would be sent back to the client. So the client would have a JWT token. So that completes this part where the user would provide the username and password. The system will authenticate the user and then it will create a JWT token. So the client would have the JWT token. Next, we will implement this part, second part, where we will have a protected controller, a protected resource that the client needs to use, but it will have to pass the bearer token, and we will write some code to parse the JWT token. The parsed JWT token, we will see if that token is valid, not expired, and if the token is valid, we will allow the client to access the resource. Otherwise, we will reject the request. Let's move on. Alright, for the second step, which is to access the secure endpoint, I have already implemented a protected controller, which is exposing an endpoint API secured. Now, the idea is that any user who wants to access anything with API secured, it has to be authenticated. All right, so there are two endpoints, one default endpoint, which is the get mapping, which says basically, hi user, you are allowed the same method. But there is another method which is only available for admin. So there is this endpoint, which is API secured /admin, and the method says, hi admin, you are allowed. And then you additionally see this annotation, which is pre-authorized, which says has role user, has role admin. So this is one of the ways to basically apply the role checks RBAC. So what would happen, let's say if the client is allowed to access this endpoint, then there is additional check to check the role of the user, whether the user has been authorized or not. The user is authenticated, that is one thing. It means the user can log in into the system, but authorization decides whether you can access a resource or not, depending on the permissions that you have been given. So that is why we are using @pre-authorize. This method, this annotation is used to apply the role checks. And here you can see the code says has role. So that means Spring Security at runtime will check the user, the authenticated principal who's trying to access this endpoint, does it have the role user? If yes, then this method access will be allowed and the user would see this response on the console, whether it is on the browser or on the Postman. If not, then it will be a rejected error. In the same way, when the user is trying to access this endpoint, the code or the framework would check whether the user has this role, which is admin, or not. If the user has this role admin, then the access will be allowed. Otherwise, the access will be rejected. So that is the protected controller. All right. Now the second step is when the user passes the JWT token using bearer token, how do we validate the token? Because the token validation would decide whether the user can access this controller or these endpoints or not. All right. So how do we validate the token? How do we intercept the request? Well, to intercept the incoming request and to parse and validate the JWT token, we will add a new filter in this case. So let me add a new file, which will be JWT filter, and this will be in the filter package. Now this filter would extend once per request filter. So as the name suggests, this filter will be executed once per request. We need to add the missing method, which is do internal. And in this method, we have access to the request, the response, and the filter chain. Because as we covered in the first video, in the Spring Security architecture overview, there are a series of filters which are executed when a request comes, and similarly, when the response goes back to the client, all those filters are executed again. So there is a chain of filters which the Spring Security framework or Spring Web will execute. All right. And in this chain, we are adding a new filter, JWT filter, which is once per request filter. The framework would internally call do filter internal this method. All right. And then it will execute the code that we will write here. The first step is we know the token would be passed in the header, all right, as the bearer token. So the first thing is we will read the value from the header. And how do we read the header? We have the access to the request object, so we can say request.getHeader. Authorization is the name of the header in which the bearer token would be passed. All right. So we will see whether the header is valid or not. So how do we check that? We say if the header is null or header does not starts with bearer, that means it's a different header. Then we do not trigger the JWT authentication part. All right. In that case, what we will do, we will simply delegate the responsibilities to the filter chain, and that can execute the next filter in the chain. And we return from this filter. All right. So if the filter is null or there is another filter which does not starts with bearer token, because we are only interested in the bearer token value, then our job is done. We delegate the control to filter chain by calling doFilter method, which will take care of the remaining filters in the chain. But if the header is present and this has the value that starts with bearer, then we know that there is a bearer token and we need to fetch the JWT and validate the JWT token. So we move forward. What we will do now, we will fetch the token from this header value. So that is going to be substring 7. Why 7? Because that is the length of this string. All right, bearer. And we know in the header, the value would be bearer and then the JWT token like this. So that is why we are simply extracting this particular part, this token value from this string. That is why the substring call. So once we have the token from the header value, we need to parse this token because we need to get the user details, its roles, and all those things that we added while creating the token. So how do we get the username from this token? Let's do that. So I will say username. And now we will use the same JWT service where we were creating the JWT token, because we need to write some code to pass the JWT token. Extract user, and then we need to pass the token value that we got from the header. Let's auto-var the JWT service. Okay. So we don't have this method yet. Let's create the method now. Now, how do we read the JWT token? Again, we will use the same samples that we got on the GitHub page of JWT Java. So you can refer to that. So we need to use JWTs dot, we call the method parser. The first step is we need to verify the token. So to verify the token, we need to use the same key. How do we get the key? We already know. We have the key here already, so we need to use this code again, and that will verify the token. Then we call the method build, and then we need to parse the signed claims. All right, because this token is signed, so the claims that we get are also signed. So we use this method parse signed claims, and then we pass the token to it. Then we call get payload, which is basically the payload from the token, and from this payload we can get the subject. So if you notice, when we created the token, we called the method subject, and in which we pass the username. That is why from the payload, while reading the token, when we call the method get subject, we will get the username back. All right, so that will return the user back to the JWT filter. Once we have the username extracted from the token, we will now validate the user. So how do we validate the user? Well, we will check if we have a matching user in the database. How do we do that? We already have the method load user by username in the user service, and we can use that method to check if the user exists in the database with the same name. So let me auto-var the user service as well. Like this, and we will say user details, user from DB, user service dot load user by username, and we will pass this username that we got from the token. So if we found a valid object from the database, then that means the user is valid because we found a matching user in the database. Okay, so what is the next step? The next step is we identified the user. The next step is to validate the token, whether the token is valid or not. So to do that, we will write some more logic here. We will say if JWT service, this is the service that we created, is token valid, and we pass it the token, and additionally we can pass the user that we got from the database, because it would have other details like roles and all those things. Okay, so this method does not exist yet, so let's create this method, is token valid. Now in this method we can write any logic that is required to validate the token. Now in this case, in this demo, we have already identified the user, we matched the user, we found a matching user in the database, so we can omit that part. We don't need to validate the username anymore. But what we can do, we can simply check if the token is expired or not, because if you remember, we added something like issue date and an expiration time, so we can check whether the token has expired or not, is it valid. So that's what we will do in this example. So let's fetch the expiration time from the token. How do we do that? Well, the same thing, JWTs dot parser dot verify with, and we can probably also move this code to a common method so that we don't have to repeat it again, but that should be fine for now. So verify with, then we call the build method, and as before, we call the parse signed claims, we pass it the token, then we call get payload, and from the payload we call get expiration. So that will return the expiry that was configured and that is available in the token. Then we can check something like this, return expiry dot before new date. So that is actually comparing the expiry time from the token to the current time. If the expiry has expired, then that means the token is not valid anymore. All right, so here we are just checking the expiry of the token. In this method is token valid. So this will return whether the token is valid or not. Let's go back to the filter. So if the token is valid, what do we need to do then? Well, that means we found the matching user and the token is also valid. So in that case, we create an authenticated principal, all right, to represent that this identity has been authenticated. How do we do that? We know it already. We will use the same token that we used earlier, username, password, authentication token. New username, password, and authentication token. And what do we need to pass it here? Well, in this case, first we need to pass the principal, and we know this is the user from the database, like this. The second thing is credential. In this case, because there are no credentials, we are using the JWT token, not the username and password authentication. So we will pass it null. The third thing is granted authorities. Now, where do we get the roles? Well, if you remember, when we created the JWT token, let's go back to the JWT service. When we created the JWT token, we also added a custom claim roles. So we will fetch the roles again from the JWT token, and we will pass it here to this authentication token so that the roles can be checked as well. All right, so let's do that. JWT service dot extract roles, pass it the token. This will return a list of roles because a user can have multiple roles. All right, and then the similar logic that we wrote here. So let me copy it from here and we'll paste it here like this. And once we have the authentication token, we need to do one more thing. We need to add this authentication to the security context holder. And once everything is done, we will again do the same thing, filter chain dot do filter request and response. So what we are doing here is why this call? Because as you remember from the first video, that the security context holder holds basically, it is a kind of a thread local object for each request, which holds the authenticated principal. All right, so when we use, for example, HTTP basic, that part is already handled by the framework. It creates the authenticated principal after the authentication. and it updates that data in the security context holder. But because we are doing this thing manually using JWT token verification, once the user or once the principal is authenticated, we need to set the security context holder so that it is available to the Spring Security framework. All right, that is why we need to do this thing. The last step is to add this method basically to extract the roles from the JWT token. So let's do that. Now in this case, we will do the same thing. So I can copy this part here. And this must be list of string. All right. So I will do something like this, parse signed claims. Then I will say get payload. And in this case, because we added it as a custom claim, which internally is a map, we will call the method get and we will pass it a key. What was the key? The key was roles. And what is the value? We want it to be a list like this. So that will return a list of roles extracted from the JWT token, which were set earlier while creating the JWT token. This is the roles key that we are passing here. All right, back to the JWT filter. Most of the things are done here. What we are doing, we are reading the header. Then we are fetching the token value from the header. We are extracting the user from the token. Then we are matching, validating whether we have the user in the system by the same username by calling the user service load user by username. If we found the data in the database, then we are checking if the token is valid. And if the token is also valid, then we are creating the authentication token, basically the identity of the authenticated principal, updating the security context holder and the roles as well. There is some problem here. Let me correct it. And this must be a mistake because now we need to convert it back from the string value to simple granted authority object. So that must be simple granted authority new like this. Okay. Now, if you notice, we are not handling any error in this case, although we should. So for example, if you don't find a matching user in the database, you should reject the request. All right. So these things we can do here in the JWT filter. Okay. We are mostly done. We are nearly done. The only thing remaining is some configuration changes in the security config to make it work. So let's do that. Now here in the authorization request section, what we were saying that any request which is matching auth, which means register, should be allowed, but any other request must be authenticated. We need to do one more thing. We need to enable the stateless session management because this is JWT and we want it to be stateless so that each request has no state of the previous request. It does not know anything about the token that was sent earlier. How do we enable that? Session creation policy. And here you can say we can pass stateless like this. And the second thing is we need to add the JWT filter. Although we created the JWT filter, but we have to tell Spring Security how to execute it, where to execute it, because there is a chain of filters. So that's what we will configure in the security config. So there is a method called add filter, and you can say before, at, after. So there are locations that we can define while adding a new filter. So we are going to use add filter before. What is the filter? Well, we have JWT filter and before username and password authentication filter. So there is an internal filter already available, username password authentication filter, but we want our JWT filter to be invoked before this filter. Now, how do we get this JWT filter? Well, that is simple. That is simply a bean. So let me do that. Bean public JWT filter. And here we will create a new object, JWT filter. That's it. So that will create the bean for JWT filter and add it before username and password authentication filter. There is one more thing missing. If you go back to the auth controller, we are auto-varying the authentication manager, but we are not configuring it. So that is one more thing that we need to do. So I will create a new bean method, and here we will return the authentication manager. How do we create the authentication manager? Well, there is this syntax that we need to use. we need to use authentication configuration like this. Now this is an object that will be created and injected by the Spring Security. All we need to do is we need to use it. So we will say configuration dot get authentication manager, and that's it. Okay, so we are nearly done now. Let's go back and simply check all the details. So we have the security config, we have the auth controller, which will authenticate the user and generate the JWT token. Then we have the protected controller, which will allow the access only if the user is valid, the JWT token is valid, and it has the right permission. Then we have the registration controller, which will help the user to register itself. Then we have the DTOs, the entities, JWT filter that we created, okay, in which we are validating the token, user repository, authenticated user, JWT service, which is kind of a utility service for JWT, and the user service. So now let me run the application and let's see how it goes. So we got an exception which says could not resolve placeholder secret key. Well, if we go to the application.yaml file, we have the secret key available. Okay, so we missed this one. So it must be jwt.secret-key. So let's go back to the JWT service, and here it is. It must be jwt dot, the full path. Let's restart. So the service is up, and if we check the database, let me refresh. So we can see we have the table users, and if we select the user table, then it must be empty because we haven't created any user yet. And we can see the table is empty. All right. So the first step is done. We have the service up and running. Now the first flow would be to register the user. Let's do that. So we will use Postman to do that. And let me go to the JWT token. The first step is to register the user. So here we have the endpoint auth register, and in the body we have 4 parameters, but for this demo we added only 2 in the login request, but we also need the role. So let me add one more like this, and I will restart the application. So the service is up, and before we move on, let me quickly check one more configuration, which is the enable method security. This is required because in the protected controller we are using this annotation pre-authorized to check the role. So we need to use this annotation to enable the method security using annotations. So that is all done. Let's go back to the Postman, and we will use username, password. We'll remove the third parameter, which is the email, because we have 3 fields: username, password, and role. So let's do that. Let's first register the user. And we can see that the user created successfully. Let's go back to the database. And let's see if we got the user. So you can see the email is null because I did the same thing in the JPA entity. I added the email field, but that is fine. The important thing is we got the role, admin, username, and password. All right. So because the role was given here, admin, fair enough. The second step is to log in and get the token. So what would happen in this case? The user would hit this endpoint API auth login. It will provide the username and the password. So let's do that. And this is now 403 forbidden. That means something went wrong in the authentication flow. So let's check the logs. So in the logs, we can see, let's check the key that was printed. So we can see the key is actually correct, but it is giving me illegal base 64 character error. And it seems I'm using an incorrect method when I'm calling this code base64.decode. So if you go to the GitHub page, and this is the section that you will find where you will find all the details how to decode or encode the keys while verifying the token. And you can see I'm using the same method which is documented here, hmac sha key for. And this is the method that I'm supposed to use, base64 URL instead of just the base64. So let me change all these method calls to base64 URL. And here as well. So let me quickly double check. All right. I will restart the application one more time. So the service is up. Let's go back to the Postman, and we will retry the login request. And this time we can see we have the token generated. So this time the authentication was successful because user provided the correct username and password, and the JWT service that we wrote created the JWT token successfully. So that will complete the first step, which is this one where the server is returning the JWT token. All right. So once the JWT token is returned, the client would store the token somewhere. And in this case, because we are using Postman, so we need to store or copy or keep it somewhere. So we will copy the token, which is the JWT token, and we will paste it in the third step, which is to access the endpoint using token. So that is the endpoint that we are going to use. If you remember, we have the protected controller that has this endpoint /API/secured, and for admin, it has the endpoint /admin. So we will try to access this particular endpoint, for which we need to pass the valid JWT token, as well as the user must have the admin role. All right. So that is the endpoint. And in how do we pass the JWT token? Well, in the authorization tab, there are various supported authentication mechanism, as we have been seeing. So we have been using, say, basic auth for HTTP basic, where we pass the username and password. We also covered API key, where we pass the API key, which is the pre-authentication. And in this case, we will use the bearer token. All right. So here it is. We will pass the bearer token. We need to replace the token with the new token. All right. Let's check the headers. And you can see there is this authorization header. And if we try to see the value of this one, let's do that. Go to authorization. So you can see we have the same token. So in this way, the bearer token would be passed in the request with the token that we provided. All right. So let's try to access the secure endpoint. And we got 403. That means we again did something wrong in the JWT filter flow. So let's check it out. Now here in the server logs, there are no logs that indicate what went wrong. So let's do that. We'll go back to the JWT filter, because this should be executed in this flow, where it will extract the JWT token and verify the JWT token. So let's add some logs here. First of all, let's check if this was invoked. All right. And then we will also print the token. And the username from the token. And then we will see if the token is valid or not. Okay. So let me add an else block here. And additionally, you can see we are not handling any exceptions. So it's possible maybe an exception was thrown, but we just don't know it yet, although we don't see anything in the logs. So let's give it a try again. I will start the application again, and we will retry the same request. Okay, so the service is up. Let's go to the Postman, and we will repeat the last step, which is access endpoint using token. We are already passing the token. Let's hit the send button, and we will go back to the logs. So first of all, we have the header, which includes the bearer as well as the bearer token in this case. Then we also got the token. All right. Username in John Doe, and token is invalid. Why is the token invalid? So you can see because the token is invalid, that is why the request was rejected, which in a sense is working fine, although we lack some logging and some proper response back to the user that we can always do. So ideally, you should handle all the exceptions here. And in case there is an exception, we should return a valid response to the user. All right, that something went wrong, so and so. So we need to understand from the demo perspective, why is the token invalid? So let's do that. We have the token, we have the user from the DB, and when we check the token validity, we are actually checking the expiry time. And this is a silly mistake, because here we are checking if the expiry is before the current date. That means the token has already expired. That is not what we want. We want, if the token is valid, then that means the expiry would be in the future. So we just need to invert the check. That was a silly mistake, and I will rerun the code. So the service is up. Let's go back and we will retry this request again. And this time we can see, hi admin, you are allowed. That means the token was valid and the user has the admin role. So the request was allowed. But what if we remove the admin? That means we try to access the other method in the protected controller. Basically, let me show you this one. So if you see, To access this method, user must have the role user. So let's see if that works. We can see 403, and that's because the user does not have the user role, it has the admin role. So we tested both the positive as well as the negative scenario as far as the role is concerned. All right. Now you can see there are gaps in this implementation like error handling, exception returning, or returning a proper response to the user. All these things I leave it to you as an exercise. But we can see how to implement the JWT service, how do we implement the token validation, creation, parsing, everything from start to finish. So just to recap, what are the steps? First, we need to register the user in the system. Then the second step would be to log in and get the token where the user would pass the username and password, and it will get a newly created JWT token. And in the third step, when it tries to access the other endpoints like secure endpoints, then it needs to pass the bearer token in which the user or the client would pass the JWT token. Then the system would fetch the token value. It will see if the token is valid or invalid, and depending on the token is valid or not, the request will be allowed or disallowed. Okay, so that's how the response will be generated by the server. So that concludes our overview of JWT. In the previous video we covered the fundamental concepts, while in this video we focused on the hands-on part. So that should give you enough idea to explore JWT further. You have the basic concepts now, you have the basic understanding of implementation, and I would suggest you check out the GitHub page of JWT. Here you will find many other details that you can use in your hands-on practice. All right. So that's all for this video. I will see you in the next one with some new topic on Spring Security. So thanks for watching and stay tuned.